Okay, I guess we don't need this. So major variables.
Okay, and two.
I agree with two continuous. How many categorical?
They call it surviving regime, right? The other post-communist regimes and former USSR.
Right, right. So is that three variables, or is that one variable with three levels? Right. So this chart has three variables, two continuous, one categorical. And what's the categorical variable? What are those three? What is that variable capturing?
They're capturing the economic development of the states within a very precise period of time. So I imagine that there's also a timing around this, because they start with a particular year and they finish with a particular year. So they're not going beyond the early 2000s, because they argue in the article that starting from the beginning of 2000s, all three levels, I mean, all countries have more or less doing okay with the economy.
Right, right.
And the major drop from this chart, of course, comes with the end of 1980s and up to beginning of 1990s.
Right.
Okay, because they suggest that the economy has come down for more than 30%. And the largest, of course, the deepest fall down happens to the post-communist, post-Soviet, former Soviet Union.
So, no, that's a great explanation. And in terms of like, why is this figure here? What is the story trying to tell? Right? There's some. I mean, to me, this figure is a very shocking figure. Like, what's the shocking part about this story?
The shocking part. If I knew the article would be so long compared to that.
Yeah.
But the shocking story is that if we are, all three levels, all countries were sharing the communist parties, ideologies for a long time. But those regimes that did not switch from communism and decided to keep these regimes, they are okay.
Right.
Because this is their black line, and they didn't have this sharp, down of the economy. The Eastern Europe, as far as we can see, because there are some numbers about Poland, Hungary. So Eastern European countries also post-communism. They also had a sharp down, but not as sharp as the USSR. Although the authors are suggesting that both had some difficult times with the armed conflicts, for example, because it happened in Eastern Europe and it happened also in post-Soviet Union countries. So the authors are saying that the best were done by the regimes like China, Laos, Vietnam, that didn't shift much about their political disruptions.
Right, right.
This way, okay, and you can see that some estimations, if you would look at one side, you will see that 30% down. But the authors are counting also with the late, let me see, with the glasses, with the 1996, okay, because they needed to reach what they have been before and then recover. So it's more than 30% at the end, okay, especially for the former USSR countries.
So I think this article is kind of responding to this democratic transition literature, right? Which is arguing that, post-Soviet era, like if you have this transition to like a market system, right, or on the path to democratization, that somehow this would be better for your country, right? But this is saying no. Like, so I mean, at least in terms of now, they all recovered by the late 2000s, right? 2010s, but so I think, well, and they're going to explain kind of the reason why this is figure 1 is because this is the outcome.
Yes.
This is the surprising outcome. Now let's go figure out why, right?
But the most interesting part is that they are trying to use the arguments in the literature review that has been discussed all the time. It's like economic standpoints of some countries, because there is a number of literature from the let's say economic nature that explains that some countries had gas and oil and they were supposed to do best. And it turns out that it's not, because there was a shutdown even for those countries as well within the former USSR. Okay.
Right.
While less oil and gas rich countries, such as Asian countries that
Right.
are describing as keeping the regimes, they didn't have this shut. So,
Right. No, absolutely. So let's scroll down and see as they try to kind of explain why this is. We've got dates of mass privatization programs. So what's this table saying? Or what variables do we have? We've got the countries, we've got the dates.
And the GDP
Mhm.
per capita, right? After they decided to do this mass privatization.
And so what's the takeaway from all of these negative numbers?
Well, the takeaway is that again, as they argued at the beginning, hypothesized at the beginning, the former USSR countries had the heaviest, harshest negative impact after the privatization has been announced, but not because of the privatization process, but because of the political disruptions and because the Communist Party had lost the assets to control. While in 2 other countries, I mean, types of the countries, this was from a different institutional level.
Right.
It was also privatization, but from a different scenario.
This is a pretty stark, this table is a pretty stark criticism of this kind of like neoliberal transitions, right? It's like not a single one of these countries had prior like positive change in GDP per capita following mass privatization. So okay, so coming down, okay. So there's one thing I wanted to show you about this graph. And I don't want to, let's see. Can you see all that? I'm trying to get it all in one. Okay. So first of all, these are not, this is not a regular linear regression model. This model is a little bit more complicated than a regular linear regression model. But what I want to show you is why did they put 1, 2, 3, 4 models here? This is a storytelling mechanism, a storytelling decision or kind of a layout. So you've got categories of. So first of all, what are they predicting? What is this? This is kind of the bread and butter. This is like the money. This is like the main kind of point of this whole article is in this table. But so what are they predicting?
The deviation and then GDP.
Yeah, they're basically predicting like growth rate, GDP, growth rates of per capita GDP. And they've got the way they've set it up is with several categories of variables. So oftentimes when you're reporting like models like this, you're going to group your variables according to your hypotheses. So remember in our table where we have like the outcome and then the explanation number 1, 2, 3, right? And then these are like the conceptual explanation. So the conceptual explanation number one is political disruption, right? The conceptual explanation number two, economic circumstances. These are very broad categories, right? Of explanations. Number three, policy and political economy. And so those are three very large conceptual ideas. And then within each of those ideas, they're actually going to measure those several different ways. So how are we going to measure political disruption? Well, first of all, we're going to look at just kind of post-Cold War, right? We're going to look at surviving regime, like whether the regime is surviving or not. We're going to look at whether they're a former Soviet Union, whether they had an armed conflict, whether they had hyperinflation. These are all different ways of operationalizing political disruption. Because the political disruption could be whether you were, whether you were leaving the Soviet Union or not, whether there was a war, whether it's right. So these are all political factors. So this paper is, why would you have so many different measures or operationalizations of the same category?
Well, with economic circumstances and policy and political economy,
Right.
that was included into this table because it has been discussed by these neoliberals in previous papers.
Right.
And this is what the authors are trying to criticize because they bring the first one as an alternative explanation.
Exactly. So the way that so model one, what they're doing with model one is putting out their hypothesis. Right? They're stating their hypothesis with no other controls. They're saying, well, first of all, we're arguing that what actually affected GDP in these post-Soviet era was political disruption. So they're going to show that, and look, all of those variables are significant, highly significant, all of them. And then here, economic circumstances, policy, and political economy. These are alternative hypotheses stated that have been long discussed in the literature. Right? What caused the change in GDP growth or like failure in these countries after the fall of the Soviet Union? Oh, it was economic factors. Oh, it was policy, like liberalization policies, whatever. Right? So with model two, these are called blocks of variables. So you can see they put it in here, this block. So what they do in model two is, so in model one, they established our variables, our explanation is significant. These are, you can tell they're all like 3 stars, 2 stars, right? And then in model two, systematically they add in the blocks of the alternative hypotheses. So in model two, you've got, this is our explanation still. And the point of model two is to show that our explanation is still significant, even after controlling for the alternative explanation of economic circumstances. Right? So what's important about the shape is the shape of this table. First, you put in your variables and show they're significant. All across, you're going to put in your variables, right? And then in the second model, you're going to show these are still robust, even after controlling for this block of economic models. And then the third one is these are still robust, even after controlling for the economic model variables and the policy and political economy variables. Right? They're still all significant. So what you want to show is no matter what other alternative hypotheses I test for, my explanation still stays significant. Now, what would have been a problem? What would have been a problem for them is if it's significant here, and then you add in this block of variables, these alternative explanations, and then these stars go away. That would have been a problem, right? Because then you would say, oh, there's some multicollinearity. Actually, this political disruption is actually maybe kind of partly explained by, that's actually a function of these economic circumstances or these policy. But the fact that these stars all stay significant, no matter what you throw against it, right, you're just showing that your hypothesis, political disruption hypothesis, is a very solid explanation, no matter what else you control for. Right? So that's the setup of this table. That's why they have models 1, 2, 3, and 4. Right? And that's how you're supposed to read this table, is that political disruption is significant, no matter what combination. So here's the economic one, here's economic plus this. And then with model 4, I'm not quite sure why they're cherry picking results, because these are just a subset. I guess with model 4, they're probably trying to show some, I don't know, some argument in particular, I have to go back and look, but model 3 is the most robust finding. Right? So, okay. Usually when they do something like this with model 4, it's like, okay, model 1, 2, 3 kind of builds up the drama, like, okay, it's still significant, and then model 4 is usually some very specific, like, sub-argument that they're trying to make. But I'd have to go back and look at what it was. So.
But even in the first part, which has got this own significance, the highest was the other company. I mean, if you would look at the numbers, most of them are having 3 stars.
Yeah.
But the very highest dramatic numbers are caused by other companies. And I think it's described somewhere in the article as far as I remember.
Yeah.
It's like -95, -0. Compared to other numbers, it's one of the highest disruption that was caused.
Yeah. What's tricky about that? So with okay, yeah, that's right. Because these are all just all of these are categorical variables.
Right.
So you can just interpret. So they are comparable in terms of their effect sizes. Yeah.
I mean, each of them is significant within their own category, like having 3 stars with this particular category. But if we break it into the separate ones, the other companies is having highest disruption, highest GDP, probably.
So this per capita petroleum output, this is interesting, right? Because this is testing the, what about if you have oil, right? And that's also significant all the way through, and it's a pretty significant effect size. But what's interesting is that even putting that in doesn't really dampen. It does affect the hyperinflation a little bit, but it doesn't do anything hardly on conflict or. It does help modify, mediate, like if you're a former Soviet Union. So if you're a former Soviet Union and you have gas and oil, then, yeah, so the gas and oil does seem to be a little bit correlated with former Soviet Union, but
not as much as it was discussed in the previous discussion.
Right.
At least this is what the authors are arguing.
Yeah, and I mean, when you add all of these effects up together too, right? That with that figure 1, I mean, it says it pretty clearly. Like this. So, okay, so what's the takeaway from this paper then? What's this paper arguing about? And like, what's its main argument?
The main argument is that basically, I don't know how many people read the first one because I'm. Maybe somebody else would like to say.
So what's the main argument of this paper? What's the most important thing for stable like GDP growth? What are they arguing is the most the strongest predictor or factor of GDP growth? Right. With these surviving regimes, right? It's political stability, right? It's the absence of radical political disruption. So whether you are neoliberal or whether you're a socialist or whether you're communist or whether you're whatever, like whether you had economic reforms or not, right? The biggest predictor of whether you have this spike, right? After transition is whether you had a transition or not. So if you have a transition, even if you implement all these positive economic reforms and these neoliberal policies and everything, at the end of the day, the regimes that had the least political disruption were the most economically stable. And looking 20 years later, all of those economic reforms, it wasn't okay, you take a dip while you're making the transition, and then suddenly these did much better, right? 20 years down the road, it didn't matter anyways, right? Which economic reforms you implemented didn't make a difference in the long term anyways. So you might as well have just stuck with. You might as well have just minimized political transitions, right? Political disruptions. Yeah, status quo. So this is really an argument in favor of status quo, right? oh, you want some like radical like economic trend? Like they better be pretty damn good because. Okay, yeah, I love this article.
The links, it was.
Walter's a really good writer too. Yeah, okay. So I think on the quiz, those are the two main ones that you need to be that you'll be accountable for. Figure 1 and oh sorry, yeah, figure 1 and the regression table. Figure table 2. Okay, next. We'll try to move a little bit faster. Horvath. These remaining two articles are also much simpler in terms of their analysis and shorter. Okay, so who wants to take natural resources manufacturing? Okay, so first set of figures, what do we got? So figure 1, what do we got here? Yeah, how many variables? Okay. Both continuous. So what are our variables? Okay. And so this is like, again, the main outcome of this paper, right? This is actually the main argument of this paper is what? In this figure, at least.
Does it exist? If yes, can institutions control? For institutions in the country, the natural resources.
Well, so what's this? I mean, just looking at this figure, you've got natural resource exports and manufacturing.
When a country exports too much natural resources, it means that they do not export much of manufacturers.
Right. So this is basically a resource curse paper, right? And it's saying countries that export a lot of natural resources don't manufacture as much. So that's just I mean, it's not a really strong slope, but you have a lot of variation in here, right? And you also have a lot of cases which are, you know, anybody that's on this line, right, is not being affected by it. Some countries export a lot of natural resources and still have high manufacturing, but the overall trend is negative, right? The question is why.
Or institutions.
Okay, so do we find is there a figure that kind of shows that? So, my gosh. I like the Walder paper because I like when you kind of group your variables, your alternative, like by like subcategories, right? And then you just have like 3 or 4 models. This one's like every single variable gets its own little test. So, okay. So the story here, this is kind of like the opposite setup from the last one, right? So for the last paper, the top block of variables was the primary explanation, Okay, and then these lower blocks were alternative explanations, right? Economic and whatever. Here, they flipped it around, right? So here, well, so they have natural resource exports, average tax rate, trade liberalization, external debt, population growth. What are all of these? These are all other covariates that you have to put in the model because they're things that affect the economy. Right? So these are not the often primary explanations, right? These are all like, so the main predictor here is natural resource export, right? You have to put that in. And then all of these other things are just like covariates that if you take them out of the model, somebody's going to whine and say, what about schooling? You forgot to put in schooling, right? Or like economic, like human capital. What about external debt? Like you can't forget external debt, right? So all of these are covariates that you're just like putting in there for robustness. And the variables that you care about are these ones, right? So as you said, the main argument in this paper, the reason for the decline. So what are we predicting? What's the outcome variable here in this regression model? So yeah, so the thing that you're actually predicting is manufacturing performance, is that level of manufacturing, right? Because the argument is if you have a lot of natural resource exports, you're going to have low manufacturing, right? And you see that as this model goes across, natural resource exports negative, 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 right? So this is their kind of main argument. Well, or this is the kind of their observation is that natural resource exports were negatively correlated with manufacturing, right? And this is significant all the way across. But what they really want to show is that it's not just natural resources. It's, as you said, it's the interaction between natural resources and institutions. So whenever you want to show an interaction effect, first of all, you have to put the marginals in, right? So if you want to show the interaction between natural resources and corruption, you have to put in natural resources, you have to put in corruption, and then you have to put in the interaction effect, okay? So here, you've got natural resources in every model, and then here, you've got corruption, and this very next one is corruption, the interaction between corruption and what's this NAT? So we've got CRP and NAT. What's the CRP? Yeah, so CRP is this variable right here. And what's the NAT? That's this variable right here. So with this interaction effect, this is the marginal, this is the other marginal. Here's the interaction between those two marginals. Okay. So the way that they set up this table is we're going to put natural resource exports in every single model, plus all these other covariates. What I would have done is block out these covariates and put them down at the bottom because I don't want to distract. Like this is the main story. Right? I would have taken these and moved them down here and moved these up because that's where the story is happening. That's the action. Right? These are just like, okay, yeah, fine, we have to control for them. And most of these aren't even significant anyways. So, or like an even more radical approach is to like collapse all of these into a meta variable called controls and just like throw it down at the bottom. Sometimes they'll do that. But anyways, so okay, so you've got in the first model, you're testing control of corruption and natural resources and their interaction. And corruption definitely affects the marginal is significant. What does that mean? What is this 5.664 telling you? It's significant. And the fact that it's positive, what does that mean?
There is no corruption.
Yes, exactly. Exactly. So, of course, natural resource exports predicts a decrease in manufacturing, but controlling corruption predicts an increase, right? And this means that, so you can also interpret this the opposite way, right? Which is, if you don't have your corruption under control, then now you get the minus 0.418, but you also get a minus 5.664. right? So this corruption is like much bigger effect than the natural resource export, right? So here, I wish they would have coded this negatively. I wish they would have coded it as corruption and not control of corruption, because here they code the natural resource export as a negative, right? And here they say control of corruption. They should have just said corruption, and then it would have been the same number, but just a minus instead of a.
Right?
Yeah. Yeah, and I guess what they're trying to say is that these are positive. These can mitigate these positive, like institutional controls, can mitigate the effects of natural resource export on manufacturing. So I guess they're trying to tell an institution story. So if you have control of corruption, you get a positive effect, and you get an additional positive effect even if you have natural resource exports. So controlling corruption plus natural resource exports is this one plus this interaction effect. So you get both of those, the bonus. And then here, rule of law. So if you have natural resource exports, it's minus 0.315, but if you have that plus rule of law, that positive overwhelms that negative, right? I mean, you get this one, plus you get that. If you even get more. So what this is saying is the fact that these interaction effects are positive means if you have natural resources and no institutions, then you just get a net negative, right? But if you have natural resources and institutions, you actually get a net positive.
Except that if there are good institutions in the country, there are natural resources. Of course, can be transferred into natural resources.
Exactly, right. So these are positive, right? If you have this institution, you get this positive, right? If you have this institution plus natural resources, you get a bonus, right, in manufacturing. If you have rule of law plus manufacturing, you get a bonus. Or sorry, plus natural resources, you get a bonus. If you have effectiveness plus manufacturing, you get a bonus. Right. The problem is a lot of countries which have these natural resources do not have these controls on corruption, or right, so that's the problem. So this is it's the flip side of the natural resource curse, right? Which is natural resources plus institutions actually predict higher rate of manufacturing. Right. So yeah, so this is that's how you kind of interpret it.
So they put Estonia as the negative example.
Does Estonia have a lot of natural resource exports?
Benefited from.
I want to see the resource, the natural resource exporter who has these, right? I don't want to see, like, I know there are a lot of exporters, like manufacturers, right, who don't have natural resources. Like those, that's not relevant to this argument. Right? What I want to see is who's got natural resources and strong institutions and is like outperforming their, whose manufacturing sector is like better than the neighbors. Yeah. The other thing I don't like about this is how they add these in one at a time. Like I mean, it's much more robust if you put them in all at once. So a lot of times, like the way I like to tell the story is, okay, add this one in, fine, add this one in, with the marginal and the interaction together, that's fine. And the last one, put them all in together, right? Like here, put in this and then put all of these in all at the same time. The fact that they didn't do that means that they made that model and it didn't look good, right? Because I know they made that model, but they decided not to put it in the paper, right? So it either messed up something here, or like some of these went in kind of not significant. Part of the reason why they might not have done that is that these things are like very highly correlated, right? So like if you have control on corruption and you have rule of law, those are like actually highly correlated, right, variables. Or if you have like regulatory quality and like government effectiveness, those are actually very high. They're basically the same thing, right? So the reason why you can't put them in the same model together is because if you have two measures in the same model for the same thing, like the significance is going to drop out because like one of them is predicting the other because they're the same thing, right? So that's probably why they didn't do the full model. Although I would like to see it just to see how correlated all these actually are. I mean, what I actually would like to see is a correlation table. So instead of like putting them in this, I want to see control of corruption, rule of law, effectiveness, regulatory quality, stability, in a correlation table, right? And see like which of these are actually highly correlated with each other. Like, so probably like I said, these probably are correlated, these probably are correlated, but anyways. And in that case, like if they're highly correlated, then don't make your table so goddamn complicated. Like just if these two are the same thing, just pick one of them and put it in, right? And if these two are the same thing, just pick one of them and put it in, and you can reduce your models from like 6 models to like 3 models or 4 models, and you're not like losing, your argument's not losing any power, right? In fact, you're gaining more like persuasive or kind of analytic power because your table doesn't look like, people don't just like look at it and like, oh my god, what is that, you know? So, and you wouldn't have to spend time like talking about like 5 different measures of institutional strength. I would have just picked like 3, right? Good stories come in 3s, I think, right? Okay. Okay, so for this paper too, we've got this figure here, right, where they're just showing there's a negative correlation between exports and manufacturing. We've got this model here. Anything else worth? This is kind of a secondary argument. Oh, look at that. Look at that. Oh yeah, this is definitely going to be on the test. Look at that. They put it as an appendix, but this is like our classic descriptive statistics, right? You got all the variables, the mean, standard deviation, minimum, max, right? This is what we're going to do in Excel, right? They would have put it at the beginning of the table. Probably the reviewer said you have too many tables, so put it in the appendix. So they just threw it in the appendix. Right? But normally this would be at the very top of the paper, right? And they've got so look at how they've grouped the variables here, right? So the reason why I like putting this in the beginning of the paper is because they tell you right away like what every variable, what the subcategory is, right? So here, manufacturing, value added, what kind of variable is that in this paper? Is that explanatory, like a predictor? Is that an outcome? Is that a scope condition? What is that? Yeah, manufacturing value added, that's like outcome. There's only one outcome variable in this paper, it's manufacturing. Okay? What's this one? Natural resource export. That's their primary explanatory variable, right? And then they've got a bunch of control variables. How do you know? Because they told you. Control variables, these are all these other things that affect manufacturing, right? Then you've got institutional quality. So what kind of variables are these institutional quality? It's not an outcome. What is that? So these are covariates or control variables, right? That's your second explanation. Your first explanation is natural resource export. Your second explanation is institutional quality, and then in the model you're going to take those 2 marginals and interact them, right? And so they interact with them. This one plus this one and that, this one and that. So the regression model does the interactions between natural resource export and each one of these one at a time, right? So this one and these are your main explanatory variables. These are control variables or covariates that you have to put in the model because they matter, but they're secondary to your argument, right? And then instruments and quality instruments. This is again probably responding to a reviewer saying maybe this is a more sophisticated topic. So sometimes, yeah, I don't want to get into instruments, but it's kind of an advanced topic in like linear regression models. So, anyways, I would have loved this. This will definitely be on the exam because it's like one of the few papers that actually has like standard, you know, like the descriptive statistics, just like we're going to do in Excel. So, okay. Anything? What does this 0.333 mean? What does this 0.333 mean on the resource richness?
average.
Mhm.
They took 15 countries, and that was 15%. Which is-
Yeah, so whatever resource richness means, they code it, you can see that when they code the minimum and the maximum 0 and 1, so what does that mean?
Three countries, very rich, Russia, Kazakhstan.
So if you see a variable that's coded 0 and 1, it's an indicator variable, right? Where 1 means yes and 0 means no, right? And in that case, what does that 0.333 mean? It's the mean. So if you have like n countries in your sample, and you average zeros and ones, it means that 33% of your sample are resource rich, and 66% are not. Okay. So the only reason I'm pointing this out is because the mean for categorical variables, which are coded 0 and 1, the mean has a special interpretation. Right. The mean is, so if you have like, I don't know, 100 cases, and some of them are 0 and some of them are 1, and you average the 0s and 1s and you get 0.333, that means 33 out of 100 of them were 1, and 66 out of 100 of them were 0, right? That's how it would have had to be to get an average of 0.333, where it can either be 0 or 1. Right? So that means that the interpretation of that is that 33% of the countries in your sample were coded 1, and 1 minus it, right? The 66% were coded as 0. Right? So that's just an extra thing you can tell when you have variables coded 0 and 1. But none of the rest of these. So except for resource richness, which of these variables are categorical or continuous? I mean, we know that natural resource exports in manufacturing are continuous because we saw that they were on a scatter plot. Right? What about these? Categorical or continuous? So if you look at this min and max, and you're getting like decimals, right? If you're not getting 0 and 1, or 1 and 2, or A and B, they're continuous. They're all continuous. So that means when they were measuring like control of corruption or rule of law or regulatory quality, right, in that when they put them in the regression model, it wasn't an indicator variable saying yes, they have it or no, they don't. It was a continuous variable on some kind of a scale, right? Where for the control of corruption, whatever that scale is, the minimum was 1.01, the maximum was 3.4, and the average was 1.83, whatever that scale is. Right? So all of these are they're all continuous variables on some kind of, on their own like scales. So you can tell that when you're looking at this table of descriptive statistics, if the min and the max are categorical variables, like indicator variables, you can tell because the min will be 0 and the max will be 1. If not, if you're getting any kind of decimals in there for the min and max values, it's a continuous variable with their own scales, right? Which means one of the implications of that when you're looking at the regression table is that like this number here, 0.231, or this number here, 1.172, or this number here, 0.181, that's the bump that you get when you have this institution and natural resource exports. These numbers are not comparable, right? Because each of these variables is on a different scale, apples and oranges. Right? So all you can tell is it's positive and it's significant. That's all you can tell, unless you dig into what's the average, and if you take two countries and you want to compare them, and like what's their control of corruption index on this scale of whatever, right? Unless you start making numerical comparisons between cases based on the indices, these numbers are not comparable across variables because their scales are all different. Right? So that's why sometimes with like economists like continuous variables, sociologists like dummy variables because the storytelling is like more simple. Like the storytelling is more you know, if it's like black, white, and ultimately categorical variables, then you can actually make comparisons across variables like a lot more easily, right? But if they're like numeric scales, then all you can tell here is significant, not significant, positive effect, negative effect. That's all you can tell. You can't really compare them. So, okay. Last article. You still with us on Zoom? Okay. Should. Yes. Okay. I hope by the end of this, you know, with quiz 2, like what I'm really hoping is that you can feel that there's some room between, like there's some kind of space for quantitative literacy, which does not require like a lot of math background, right? Like you don't have to be an expert in like linear algebra or calculus or you know, like differential equations or something to be able to look at a regression table and make sense of it, right? And you, like you can I want you to just realize that you can digest quantitative figures or tables qualitatively, right? Stars, no stars, positive effects, negative effects, like how is the information organized, right? That's the quantitative literacy. So you don't have to know, you don't even have to know how to do a regression model or like the math behind it to be able to look at a regression table and confidently say like, okay, first of all, what's the storytelling? How are they setting up? Okay, what's the outcome of the table? Here's their main predictor. Here are these controls. Okay, these are the main, you know, are these blocks of variables like their main argument, or are these kind of alternative explanations that they're controlling for, like figuring that out, and then seeing like what's significant, what's not significant, is it a positive effect or negative effect? Like that's what I want you to get out of it, right? You don't have to know beyond that, like how to use the software and wrangle the data and like build the models. Right? So okay, number 3 is all as pathways to corruption. So institutional context and citizen participation in bureaucratic corruption. Oh, the other thing is when you've got quantitative papers, a lot of times you can skip like reading a lot of stuff by just like looking at the figure. Because if they do the figures well, you can just jump from figure to figure and tell like kind of what's the main argument, right? Like, okay, first, okay, that's the money shot for like the main argument, and then let's go into the analyses, right? And you just kind of hop like figure to figure, and you don't have to like waste a lot of time. I mean, not every article deserves a thorough reading from from start to finish. Okay, so here's the theoretical model. What's this saying?
This figure shows that corruption behavior depends on many factors, such as female, age, education.
Location of living.
What's this utility?
Utility is something like
What's the utility? Like your gas bill, like like your electric bill? What's the utility here? So what I don't like about this paper is they don't have like one very clear kind of figure. Like the other two papers had like figure number one. It's like boom, here's the graph.
No, there are no graphs.
Right.
Utility, zero meaning of utility is like efficiency, like no, like a benefit or something efficient, something useful.
Right. So let's look at their hypotheses first. Let's kind of, at least they have hypotheses clearly stated. So hypothesis number one, the more acceptable citizens think that bribery and gift giving are, the more they're likely. Okay, so this is just norms, right? Social norms. Number two, lower risk, right? So the less risk there is associated with the bribe or corruption, the more they'll do it, right? So cultural norms, lower risk, lower perceived risk of detection and punishment. Much more common if officials are proactively engaging in it. So if officials request bribes, citizens are more likely to engage. Okay, the utility of the as the utility of the transaction increases, the likelihood also increases. So bribes without utility, right? And this is one of the, like in the literature on party clientelism, right? Like in developing countries, like in democratic countries with weak political institutions, right? The politician can go out and say, just give some money and say, hey, vote for me, right? I'll give you like $10, right? But the more that your country develops, right, as your average like income raises, the GDP per capita raises, right? Like $10, what's that? Right? Like what? Right? At some point, like the GDP raises beyond what politicians can meaningfully give, and then this petty corruption is like the utility is lower, right? But if you don't have any money, like $10 is like, whoa, okay, sure, I'll vote for you, right? But if you're making like $2,000 a month, it's like, I don't know, like I'll pass, not worth the trouble. The more acceptable citizens think the bribery and gift giving are, the higher utility they attribute. So this is kind of second order like beliefs. Okay, you think that it has higher utility. All right. So, anyways, I would have loved to see some descriptive table here, kind of illustrating their point, not just the theoretical model. But this is good. Okay, so let's get down to the. At least they have. What is this? These are what are they? What are these?
It's like how I can say it's government authorities. Yeah, government officials who could be somehow connected to corruption.
Okay, so this is like the opportunity for corruption, right? If you had no contact with these people, like we're not gonna survey you because you had no opportunity for bribes, right? So this is how they're operationalizing, right? They're operationalizing contact with government officials, right? And they're actually listing them like one by one. Which I like this because it would have been a lot different if they just operationalized it like one kind, but not all the other ones, right? So, and then, okay, what's this? This is also an operationalization of what?
It's kind of right.
Right. So there's more than one way to be corrupt. What's this?
Like options.
So this is another operationalization of responses to a question about why. So this is kind of about perception, right? Like why they think people engage in corruption, all these different ways. Okay, so analysis and results. Gosh. Okay, So you might recall. This paper is this is an interesting paper. I feel like the person who wrote this is probably old because first they did a t-test. So they're doing a t-test and then they're doing an OLS regression, which is kind of redundant because so I don't think I included it in here. Anyways, like this is so imagine in the last paper that we looked at, the manufacturing with the natural resources, right? And then you want to test like if you don't have like regression model, you can just take manufacturing level, and then you can have two groups, like countries which have high natural resource exports and countries which don't. And you can calculate the average manufacturing for these two countries, two types of countries, and then see if that difference is significant or not. That's essentially what a t-test is doing, right? But come along regression, you don't just do that. You don't just put in the natural resource export. You put in like 5 covariates and then a bunch of other things, right? So you're not just testing natural resources on manufacturing, you're doing that plus all these other variables, right? So t-test is just looking at like one explanatory variable on one outcome. And the reason why you do this instead of a regression model is because there used to be a time before computers where we couldn't calculate fancy regression models. And so a t-test was like the best you could get to calculate whether that correlation was significant or not, right? But nowadays, almost nobody uses this because like you can put that predictor in, and then you can add like 100 covariates, and it, you know, and your computer's still going to do it in like half a second, right? So why put this in here? It's kind of a throwback to like pre-computer days. So I don't know why this is very strange. So this will not be on the test. But this one will. So now they did the exact same thing, but it's a regression model with everything that we wanted, like plus all the covariates. So corruption behavior on theoretical predictors. How am I supposed to interpret this graph? What's the outcome? This is a regression model, so what are we predicting? Corruption. So we're predicting corruption behavior, right? You've got two cases. So they're modeling this like in a 2x2 with Russia and Ukraine in non-conflict and conflict areas. Again, unnecessarily complicated in my opinion. But so the dependent variable is corruption behavior. Then you've got these like 4 cases. Right, and then for each of these, they're modeling these factors. So, which of these are primary predictors, and which of these are covariates? Yeah, so belief in acceptability is a primary predictor. How do you know? So you go back to the hypotheses, right? Remember hypothesis 1?
We have 3 hypotheses. And the first was about it's like opinion of people in how they think, how they believe is the opportunity to learn.
Right. So that belief in acceptability, that was hypothesis 1. Hypothesis 2 was they think the risk is low. hypothesis 3 is, and then 3 and 4 is this kind of or 3 is this utility, right? That the risk goes up. Sorry, that the corruption goes up if there's utility. And then the spread of corruption was the it goes up if the officials ask for the bribe, right? So these are your 4 hypotheses. What, and then rural age, female and education,
It was like factors that influence on the corruption level or something.
right?
In the scheme that we have. Going.
Yeah, exactly. So these are covariates. So I would have preferred that they could have divided those up, like they could have put in a little subtitle here saying covariates, right? And then these are like predictors. That would have been a cleaner way to make this table, right? But anyways, and sometimes you even put in like a little H1, you know, H2, right? Why not? Like, why not make this easier to read? Right? But anyway, these correspond to hypotheses 1, 2, 3, and 4. Okay. And then, oh, sorry, no, spread of corruption is something else. This is with utility. This one is with the official requested bribe. So this is the hypothesis 4 when the official is requesting a bribe.
Spread of corruption, maybe it was about like allocation.
Yeah, I think you're right. I thought the spread of corruption was this official requesting bribe, but they decided to model that separately. This is a really, I would have, okay. So anyways, what do we find about these hypotheses? So belief in acceptability, does it significantly predict corruption? Yes or no? Except where?
Except the conflict zone area in Ukraine
Okay,
and conflict area in Ukraine with official requested bribe.
right. So for whatever reason, conflict areas in Ukraine is somehow like immune to all of these hypotheses. Right? But for every other region, right? So belief in acceptability, significant. What about punishment, risk low?
It's plus non-conflict area Russia is official requested bribe, conflict area of Russia and Ukraine non-conflict area and the conflict area as well.
Right. So this official requested bribe, when they put it in the model like that, then essentially what they're doing is it's an interaction effect. Right. So this is where this is belief in acceptability without the official requested bribe and with the official requested bribe. Right? And it doesn't change. Right? I mean, it's equally like predicted. Although when the official requested bribe, the belief in acceptability goes down, and that's probably because those are correlated, right? Which makes sense, right? If the officials are asking for the bribe, you're likely to think it's like acceptable, right? Because otherwise they wouldn't be asking. Okay, and then when the punishment is low, punishment risk is low is not a predictor when the official is asking for it, because again, those things are highly correlated, right? Like if the official is asking you for the bribe, you're probably not worried about, well, I don't know, like it's, yeah, maybe the significance goes away because they're correlated. Okay, utility. So this is interesting. Utility predicts corruption or no? Not really.
Only
Only in one case.
Yeah, only in one case and not in the other ones. So what's this? So what's this table telling us? I mean, that to me, that's the oh my god, like finding in this table.
Number 3 doesn't work actually.
Yeah, and like interpret that for me in a more like shocking way. What's like the shocking takeaway from this table?
But we don't have any estimations with official requested bribe.
Yeah, I don't know why they omitted it from there.
But I think that what it means, it could be.
Well, you assume that there's utility there when it's right. So this is where
Maybe we don't have because like it's utility and with utility it's with official requested bribe. Yeah.
yeah,
We cannot have estimations here.
right.
Utility is like a benefit or
Yeah, a benefit.
Something useful.
benefit for those who.
Yeah. So the more
So they know other ways how to solve their problems without.
I think they're saying that giving a bribe or not giving a bribe is not it's not an economic rational. You're not giving a bribe because you think you're going to get something for it, right? It's like it's a normative practice, but your decision to give the bribe or not is not based on any kind of rational calculation that you're going to get some benefit for this bribe. So it's either like normative or no, I mean, it could be, I don't know if they're measuring utility at like a negative utility, right? So sometimes you think about access money. Access money is different than like extortion, right? So access money, it's like, if I give you this bribe, you will speed up my request for this permit, or, you know, you will like help me, get the business permit faster, right? Right. But sometimes with corruption, like bribes can also be to avoid penalties, right? So basically, like when the police officer comes and pulls you over and asks you, like, can you help me out? Right? He's not asking, like, if you give him that money, he's not going to like drive you. He's not going to like fill up your gas, right? There's no utility there, right? It's like avoiding a penalty. But I don't know if, with utility if they're measuring like both sides of the positive and the negative utility, or they're just looking at positive utility. But anyways, to me, this showed like this supports this idea that corruption is not this kind of rational process where like we pay money in order to get some benefit, right? It's just a normative cultural practice, right? And if officials ask for it, you give it, and the less risk and the more acceptable you think it is, the more you do it. But it's not because you think you're actually gonna like get some benefit out of it. So what about these? Sometimes the covariates are kind of fun. What about rural? Are you more likely to be corrupt if you live in a rural area?
Yes.
Yes and no.
Yes, and except on the one case with not there. So we have negative, and the,
So in Russia and Ukraine is different.
yes, yes, in Russia, it's not.
So in Russia, it's more urban corruption is more prevalent than rural corruption, and in Ukraine,
Vice versa.
vice versa. That's interesting. I wish I knew more about what this actually meant, right? Like I'm trying to like imagine in my head, like I mean, in Russia, it's like, you know, bureaucrats in some like social welfare office, and in Ukraine, it's like, you know, cops in the countryside. I don't know. It might be totally different, like doctors or something, country doctors. Age, okay, female, no, nothing. Education. But I mean, what's interesting is like for Russia, non-conflict, like all of these things are loading, but in other places, not so much. So I'm also kind of curious if this Russia, if somehow their sample is different, right? They either like sampled more people. It could be that they just had a better sample for this, right? And then these are like smaller samples, right? Especially conflict areas.
Maybe we could look at limitations.
Yeah. Yeah, I look at limitations. I'd also look at like sample sizes, right, across there. But anyways, I don't like this paper so much. Oh yeah. Oh, here's the official requested bribe. Yeah. God damn it! This paper is so. So basically, this model, like we're putting in the utility here. This model we're putting in the official requested bribe at the bottom. Yeah. Yeah. So I think the takeaway from this is the utility plus this one, right? Which is that you're not doing a bribe because you think you're getting utility out of it. You're giving a bribe because the official asked for it. Yeah. Okay. Yeah, okay, so this table will be compressed into a single table and could be on the exam as well. Structural equation model is very complicated modeling, and it's not very popular anymore, except in social welfare studies, education. So that will not be on there. Okay. All right. So we're done with those. Excel. Any questions on the 3 articles? Which of these articles was most interesting to you?
First one. Oh, no.
First one? Anybody else? Anybody else have a different favorite? Oh. Which of them do you felt like had a good storytelling, like use the graphs to the best of their abilities?
First.
If you had to rank them from like best to worst, how would you rank them? Okay.
But I will put like the third one to the third, the second to the second, because in the third we even didn't have any graphs and the table were so complex.
Yeah, yeah. I think in terms of storytelling, so one thing I just wanted to show you there was like, each of those had a regression table and each of them are setting those regression tables up in different ways to tell stories, right? So I think that's what I wanted, that's the main kind of reason I wanted you to compare these 3. Okay, I'm gonna stop recording and start recording for the Excel.